Does the following reaction undergo an SN2 or an SN1 reaction? What are the products formed? Add lone pairs on the appropriate atoms and place full and partial charges on the atoms. Identify the nucleophile and electrophile. The nucleophile in this reaction is methanol, which is a poor nucleophile and a weak base. The electrophile is the alkyl bromide. Is the electrophile accessible to a nucleophilic attack, or is it sterically hindered? The alkyl halide in this reaction is tertiary. It is sterically hindered towards a nucleophilic attack and will not undergo an SN2 reaction. Is the solvent protic or aprotic? Methanol is also the solvent. It is a polar protic solvent which can hydrogen bond and solvate ions. This is enough information to determine if an SN1 or SN2 reaction will occur. The solvent is polar protic, which helps promote an SN1 reaction. The alkyl halide is tertiary and will not undergo an SN2 reaction. This is an SN1 reaction. Use arrows to illustrate the mechanism and show bond formation and breaking. These arrows will show you what your products are. The first step in an SN1 mechanism is the formation of a carbocation. Your first arrow shows the electrons from the carbon-bromine sigma bond moving to the bromine atom to produce the carbocation and the bromide ion. The carbocation is a strong electrophile because the carbon does not have a full octet. The weak nucleophile now reacts with the strong electrophile to form a new carbon-oxygen bond. Negative goes to positive. I did not want to draw the last step in the mechanisms, so I used a -H+ on the arrow to show that a hydrogen is removed by the solvent in the last step to produce the ether. Notice that the ether produced in this reaction has a stereogenic carbon. This carbon has an S configuration. Since the carbocation intermediate is sp2 hybridized and trigonoplanar, methanol will also attack from the other face to produce the R enantiomer. We can redraw the R enantiomer as the mirror image. If we assume that there is an equal probability of methanol attacking from either face of the carbocation, the enantiomers will be produced in a 1:1 molar ratio to create a racemic mixture. A solution of the products would be optically inactive.